Hello, in this video, we are going to use integrating factor method to solve a first order ordinary differential equation. To use integrating factor method, these are the steps. The first step is that any equation must look in form of this dy ds plus p of x times y equal to q of x. This is step 1. Step 2 is the integrating factor, which I call if, is equal to e to the power of integral of p of x ds. The third step is multiply the equation by if. Now let us solve this first order differential equation. Dy ds plus y is equal to x. By comparing this equation with this, you will see that they are of the same form. Dy ds, y, we have y. That means our p of x here is 1. So p of x is equal to 1. And comparing this right hand side, q of s is equal to x. Q of x is equal to x. Now let us solve. Step 2 is to find the integrating factor. So our if is equal to e raised to integral of, what is p of x? That is 1. So we have 1 ds. This is equal to e to the power of, when we integrate 1 with respect to ds, that is simply s. So our integrating factor is equal to e to the power of x. Now, step 3. We have to multiply the equation by integrating factor. So let us multiply this equation by the integrating factor. This implies that we have e to the power of x times dy ds plus y times e to the power of x equal to the right hand side, x times e to the power of x. This means that this whole left hand side could be written as dds of y times e to the power of x equal to x times e to the power of x. That is, by product rule, you will arrive at this left hand side back. Let's proceed further. Now, integrating both sides with respect to x, we are going to have y times e to the power of x equal to integral of x times e to the power of x ds. You have to be very careful here. This right hand side, we can only solve it using integral by part formula. So let us solve it individually using integral by part formula. Integral by part formula says integral of u dv is equal to uv minus integral of v du. Just take note of this. By comparing this left hand side with this, you will see that our u is equal to x and integral of dv is equal to integral of e to the power of x ds. That is, our dv is just e to the power of x. When we integrate, we have this. Let's solve this first. Du ds is equal to 1. So this means that du is equal to ds. Now back to this. Integrated dv, we have v equal to integral of e to the power of x with respect to x always gives e to the power of x. So this is our v. Take note of it and this. Now let us input all these values into this right hand side. So that means integral of x times e to the power of x ds. That is, our u is x and our dv is e to the power of x ds. This equal to uv, that is product of x and e to the power of x times e to the power of x minus integral of v, that is v du, that is e to the power of x times ds. E to the power of x times ds. This gives x times e to the power of x minus, whenever we integrate e to the power of x with respect to x, we always have e to the power of x. This means integral of x times e to the power of x ds is equal to this. We can now substitute this value into this right hand side. Doing that, we have y times e to the power of x equal to x times e to the power of x minus e to the power of x plus constant of integration k. Let's divide both sides by e to the power of x. So that will be y e to the power of x divided by e to the power of x is equal to x times e to the power of x divided by e to the power of x minus e to the power of x divided by e to the power of x plus k divided by e to the power of x. Clearly, e to the power of x cancel each other. We are left with y on the left equal to e cancel each other. They also cancel each other here. We have x minus 1 plus k. Suppose we want this denominator to be at the numerator, it becomes e to the power of negative x. This is the required solution. That's it.